Hello, everyone. Good afternoon. Today's lesson is about AI technologies, natural language processing, and computer vision, and also foundational models. AI technologies and applications are AI has a lot of technology and application fields in various field of studies. For example, AI technical field. These are natural language processing, computer vision, robots, and recommendation system, and also other technical fields. Um AI has three fundamental development trends. From that, one is algorithms. AI algorithms have a lot of algorithms. From that, these are some of AI algorithms and computing power. From computing power, chips, servers, and cloud computing are included in computing power. And data is one of the fuel of AI, and it's the data warehouse of AI. It's sensors, multimedia data, and storage are in this data service. This smart education, intelligence driving text to image, a smart healthcare, voice assistants, and smart manufacturing are applications of AI. These are application of AI. These are the graphically described in this way. AI has a lot of popular subfields. From the some of AI fields. One is content review, object detection, autonomous driving, machine translation, medical imaging, intelligence customer service, a recommendation system, integrated circuit design, machine learning, computer vision, natural language processing, or NLP, big data, expert system, database technology, and so on, have a lot of uh, uh, subfields. Here are some. These are some field of, but they are popular. Distributions of AI applications. AI applications are distributed in different technologies. AI is commonly applied in the following technical fields. One is computer vision, natural language processing, and multimodal and others. These are some. Computer vision is one, and natural language processing and multimodal AI distribution applications. After here, it's natural language processing. This is the next topic. Natural language processing is a branch of computer science and artificial intelligence. It studies theories and methods for implementing effective communication between humans and computers through natural language. It is the basic idea through natural language, not artificial language. NLP is intended to enable computers to understand and generate human languages. understand and generate human languages. It have three development phases or rules. One is a rules and linguistic theory. The second phase is machine learning and deep learning. And the final stage is large language model or LLM. It's a large language model. Natural language processing have a lot of applications from that it's sentiment analysis in social media, text mining, machine translation, chatbots, and other have some of applications of natural language processing. AI applications in natural language processing. The applications of AI in natural language processing. One is text classification. Text classification. The second one is text summarization, information extraction, information extraction. Sorry, extracts key information such as entities and relationships in knowledge graph from massive text data to support data analysis and decision making. It is the third application of AI in natural language processing. It's a machine translation automatically converts language into another language. For example, English to Chinese or Chinese to Amharic or Amharic to English. This is one application of AI in natural language processing. It is machine translation. Smart writing. It assists in generating a high quality text such as news release and advertising copies, improving content creation efficiently. This is another application of AI in natural language processing. How is AI work in natural language processing in text classification? It classifies texts in this from the definition. It have input. For example, the input is article D. That this article the input is an article and it has a fixed category set. It must be known category data set and after the input is obtained, it has an output or it's a predicted category for the article. And also natural language processing task is sequence labeling. It's in sequence labeling using a model to label each positions of a given input sequence, usually a sentence, character, or word in text, to form a label sequence. This process may be viewed as a sequence-to-sequence mapping. It is one algorithm in AI. It is used to in sequence-to-sequence mapping. Applications of AI in natural language processing and text generation. A text generation is a process in which an algorithm automatically generates grammatically sound and meaningful text content. It is one application of AI in natural language processing. This technology can simulate a human writing process and generate various types of texts, such as news report, emails, articles, social media posts, poems, novel chapters, and so on. It generates or this algorithm automatically generate grammatically sound and meaningful text in this field. Generally, in this field, it works. Another application of AI in natural language processing is knowledge graph. This graph is uh, entity relationship application. Knowledge graph is it is a graphical data model to represent and organize structured information. It represents entities such as, for example, people, place, and thing in database in the real world and their relationship such as friendship and affiliation have a relationship. It's a friendship and affiliation have a relation in the forms of graph to construct a large-scale multi-domain knowledge base. It's a knowledge graph application. Natural language processing or NLP provides the means to build a knowledge graph. NLP helps extract information such as entity, relationship, and attributes from text to build an enriched knowledge graph. This is an example of knowledge graph. For example, I have psychology, philosophy of mind related in this direction, cognitive psychology related in this direction, and this cognitive psychology is a relation with other connectionism and so on. Here are the applications of AI in natural language processing as a knowledge graph. The other topic is computer vision. It is a current mainstream application and technology. Computer vision is a technology that uses computer and algorithm to simulate the process of human vision. This is the basic idea of computer vision. It's a technology. It's a technology that uses computers and algorithms to simulate or mimic the process of human vision. It involves extracting information from images. It involves extractions of information from images, videos, analyzing and comprehending content and making decisions accordingly. These are the functions of computer vision. Computer AI application in computer vision in image classification, object detection, semantic segmentation, video imprinting, intelligent driving, and so on. Have a lot of applications in computer vision. It's one is image classification, uses extensive amounts of unlabeled data to improve the representation capability of models for applications in various general scenario. That is a principles of image classification. Object detection. It is a very popular applications of AI in computer vision in object detection. Identifies and in, for example, this object detection application apply in military science, mostly applied, and semantic segmentation assigns predefined class label to each pixel in an image Implementing pixel level image understanding. It understands in pixel level image and video implementing, intelligence driving for out veils. It's one tasks of computer vision and object detection. It detects objects. Object detection is one of the fundamental technology for image processing and computer vision in the AI field. It has a wide range of applications such as traffic monitoring, like this. From this, look at the image of this, the image of cars in this road. Image search, facial recognition, human-computer interaction, object detection technologies can help detect objects in an image for further processing with intelligence algorithms. Here are the tasks of computer vision and object detection. The other task is image segmentation. Image segmentation is a process of partitioning an image into multiple segments based on the problem to be solved. Okay, it's partitioning an image into multiple segments based on the problem to be solved. There are many algorithms and applications method for image segmentation. Common one include connected component segmentation and motion segmentation, object segmentation. These are the three algorithms. It's a connected component segmentation, motion segmentation, and object segmentation have a different application and different algorithms in image segmentation. For example, object segmentation, it's, uh, it's semantic segmentation and instance segmentation. Semantic segmentation refers to the pixel-level image segmentation, that is, marking the object category to which each pixel in the image belongs. So, which each pixel in the image belongs. Instance segmentation is a task of identifying each instance of object from an image and performing pixel-level labeling in each of instance. This is the idea of object segmentation. Segmentation is a pixel level description of an image and makes each pixel category count. It is applicable to scenarios with high requirement for understanding, for example, segmentation between roads and off-roads. Roads and off-roads. That's work in unnamed driving. This is the idea of image segmentation. The other task is computer vision is object tracking. Object tracking is a core research area in computer vision and has a wide range of applications such as intelligent transportation, security monitoring in cameras, human-machine interaction, and autonomous driving. Tracking algorithm can obtain the trajectory of target object in terms of time to analyze their environment behavior. It works in a reinforcement learning. The final and the last task of computer vision is optical character recognition. It is the process of recognizing characters in an image or a scan and converting them into a editable one using image processing technologies such as character object detection and object classification. These are technology, object classification and character object detection. These are two different technologies. OCR improves service efficiency by sparing a manual information input. OCR can use to identify characters in ID cards, driving license, vehicle license, invoice, customs form, general tables, and general text. OCR applies in this area. Generally applies in this whole area. It's an ID passport OCR like this. As okay, how another task, image generation. Computer vision task applies in image generation. It generates image in different ways. One is generate a new image or generating an image from the existing image, and the last one is editing the image. Image generation refers to the generating a wholly new image, modifying part of an image, or generating new images that based on the existing one. Super resolution is a process of estimating high resolution image from low resolution counterpart and predicting image feature at different magnifications. It is a super resolution. Style migration is a process of applying style of one domain or several images to another domain or image. This is style migration. Image imprinting is the process of fixing image. It is the process of fixing image. The last topic of our today class is foundational model. Foundational model refers to a model that is trained on large scale data and has a massive number of parameters and has a powerful functionality. It is a foundation model. It's a foundation model trained on a large scale data set and has a massive number of parameters, and it has powerful capabilities and functionalities. Foundational model have a large capacity, a large size, have a high requirement for computing power. It have inference. It has a strong capability and a large knowledge base. These are the characteristics of foundational model. A foundational model have different principles behind their large model. One principle is the scaling law, Chinchilla law, and emergent abilities. These are the laws of foundational model. A scaling law, as the model size increases exponentially, the model performance increases linearly. This is exponential to linear relationship in scaling law. And the second one is a chinchilla law. This model, the model size and the number of training tokens should scale at equal rates. It has 1 to 1 or equally decrease and equally increase the relationship. These are the chinchilla law. When the model in emergent abilities, when the model reaches a certain size and scale, it shows a sudden and unexpected improvement in performance and generalization capabilities. These are the emergent abilities of a foundational model or a large language model. What makes a model large? What makes a model large? Large scale data. It is one of the sorts of large scale, a large model. Extensive data to cover nearly all real-world scenarios. Large-scale model. Large-scale compute. These are a large model characteristics and uh, a large model have a lot of problems. From these problems, these questions are basic questions of large model or large language model. Where does a foundation model come from? This question is a basic question, and this question is answered from this graph. Foundational models are came from a transformer. Transformers are classified into three: encoder, decoder, transformer, encoder only, decoder only. These are the algorithms of AI. All of them are algorithms. These are only decoder only. These are decoder. These are encoder and decoder algorithms. And these algorithms or implementation way of AI is encoder only. We will later we will discuss more deeply for each large language algorithms. Okay, as a very necessary data set um, have a data scale and data diversity. Small models, and it's a comparison between small models and large models. A small models in data scale. Dataset usually contains million or tens of a million of data records. It has million or tens million of data records. But in large model, large models need to process and learn more complex relationship and pattern and therefore require large data sets. For example, it's one question from this table in your certification exam. This is it is a small data scale, and this is for large model. It have a large data scale and data diversity. For a small model, the data usually used for a specific task for or domain, a specific domain or specific task. But in large model, a dataset involves multiple domain and topics because of its large model. Okay. Look at this image. These are a small model and these are large model. In a small models are light and highly efficient, but it's a single task. They are suitable when resources are limited and only one task needed to be performed. But in large models feature high processing capability. It is uh, high processing capability and accuracy. It has higher accuracy than smaller models. They are suitable when high complexity and accuracy are required. Its high complexity and accuracy are the most and the features of large models. Okay, okay, this the last topic. AI breakthrough driven by foundational models are emergence. Emergence. Currently, two task types are considered to express emergence. What's emergence? One is in-context learning, or it's a traditional way of learning, and chain of thought it is the most suitable and the current mainstream of thought in AI. In-context learning helps algorithms understand the meaning and relationship among words in a sentence and recognize the relationship among different objects in an image. A chain of thoughts or code users write down step-by-step inference process and provide them for large language model. It applies in large language model, so it can perform some complex inference tasks. Today's lessons are here. Thank you for your listening. Bye.